electrolytes already. What are the common ones that we were talking about? Let's bring it back. Bring it back. Sodium, calcium, potassium, magnesium, phosphorus or phosphate, yep. What is the purpose of them? To keep us alive. Homeostasis, that balance. We have to have a good balance. If one's off, another one's probably going to be off, and we're going to feel the effects of it. So water regulates body temperature, helps lubricate joints, serves as a shock absorber for internal organs, and transports nutrients and waste products throughout the body. Our total body water, or TBW, is the percentage of body weight that consists with water. Most body fluid is intracellular fluid. What does that mean? Intracellular. Within the cell. Extracellular fluid, what's that? Outside of the cell. Fluid that is outside of the cell. And then we have interstitial fluid. This fluid is between the cells of the organ or tissue, and it accounts for approximately 25% of total body fluid. We have intravascular fluid, which is like blood plasma. This accounts for approximately 8% of our body fluid. We have transcellular, which includes cerebrospinal, synovial, peritoneal, pleural, and pericardial fluids. Cerebrospinal, that's like our spinal fluid. What about synovial? In joints, between joints. Peritoneal. It's in our stomach. Yeah. Pleural. Lungs. And then pericardial. Around the heart. Yep. Then we have solutes. These are chemical substances that dissolve in a liquid. Solutes that dissolve easily are called crystalloids. Substances such as proteins, which do not dissolve easily, are called colloids. Electrolytes are charged atoms or molecules, you might hear the term ions, that conduct electrical impulses across cells. So we're going back to A&P just for a little bit about how water moves and what that process is. So osmosis, I know we've all heard that term before. Osmosis is the movement of water across cell membranes. Water moves by osmosis from an area of lower concentration of solids to an area of higher concentration of solids in an attempt to equalize the concentration across the membrane. The higher the difference in concentration of solids, the greater the osmotic pressure. And then, like we just said, fluids and electrolytes are always moving, always changing to help maintain homeostasis. Homeostasis is just a balance. So with our osmotic pressure, this is a force created when two solutions of different concentrations are separated by a selectively permeable membrane. What does that mean? Only certain things can get through, absolutely. The cell membrane allows the water to move across, but not the solutes. Osmolality. This refers to the number of osmoles, which is the unit of osmotic pressure, per kilogram of solvent, which in this case is water. Osmolarity is the number of osmoles per liter of solvent. In discussions of body fluids, the differences between the two values are very, very small. Then we have the term tonicity. This refers to the level of osmotic pressure of a solution. So then we have an administered solution that has the same osmolarity as blood plasma. We would consider this to be an isotonic solution. Normal saline or 0.9% sodium chloride would be considered isotonic. Fluids with a higher osmolarity than body fluids are considered to be hypertonic. And we'll talk a little bit more about those terms in just a second. A hypertonic solution pulls water from the cell to the extracellular fluid compartment, which causes cellular shrinkage. Solutions with a lower osmolarity than body fluids are considered to be hypotonic. What do we know about hyper and hypo? Hyper is high, hypo is low. With our hypotonic solutions, excess water moves into the cells, which produces cellular swelling. And then our osmotic pressure in the intravascular space is controlled by concentration of plasma proteins, specifically albumin. This is known as colloid osmotic pressure or oncotic pressure. Because these plasma proteins are too large to pass through the capillary membrane, they hold fluid in the intravascular space. With filtration, this is the process by which fluid and solids move together from an area of higher pressure to one of lower pressure. Water is lost from the body primarily through which organ? The kidneys, yep. And then it is excreted as urine. Homeostasis, maintenance of fluid balance, is controlled by several physiologic mechanisms, including the renin-angiotensin system, the secretion of antidiuretic hormone, and our thirst mechanism. The renin-angiotensin system regulates blood pressure and fluid balance through vasoconstriction and excretion or reabsorption of sodium. Our antidiuretic hormone, which is secreted by the pituitary gland, helps maintain serum osmolality by controlling the amount of water that is excreted in the urine. We've talked about this. What lets me know that I'm not getting enough water, that I'm dehydrated? Dark urine. Yep. Probably not a whole lot of urine either. We're going to be dry. What about if I'm getting too much water? It's going to be clear. Is that good? No, because there's no waste products in there. I'm getting too much water. We want it to have like a pale yellow color. Homeostasis is monitored by the kidneys through changes in blood pressure. And then the way that the body increases fluid is through the angiotensin II, which is a hormone that causes vasoconstriction. What does that mean to vasoconstrict? Narrowing blood vessels, yeah. Stimulation of the adrenal cortex to help release aldosterone, which acts on the distal convoluted tubule of the kidney to increase the amount of water and sodium that is reabsorbed back into the bloodstream. Our antidiuretic hormone releases, and then the thirst mechanism is stimulated. With our osmoreceptors, which are located in the hypothalamus, they monitor the osmolarity of the blood plasma. When our osmolarity increases, becomes more concentrated. So if our osmolarity becomes more concentrated and a lot more solids, what are we going to be? Are we going to be hydrated or are we going to be dehydrated? We're going to be dehydrated. They're going to stimulate the posterior pituitary to secrete our antidiuretic hormone, or ADH, and then the kidneys then act to help reabsorb more water. Aldosterone can also stimulate the reabsorption of water and sodium, which increases volume, but doesn't affect osmolarity. If aldosterone affects the reabsorption of water and sodium, what do you think it will do to the urine output? Increase it, yeah. Good. So let's talk about hypotonic versus isotonic and hypertonic. Hypotonic, we have a solution with a lower osmolarity than body fluids. I have more water than I do particles. So the particles is what I'm looking at. I'm low on particles. Excess water moves into the cells. It produces cellular swelling. If you think about when you have too much water in your body, what happens? I start to swell. I start to get edematous. Yeah, because that's extra fluid. Hypertonic, I have more particles than I do fluid. So I have cellular shrinkage. I'm going to be dehydrated. I've got more particles to deal with than I do water, and it's taking that water away. So what am I going to look like here? I don't have as much fluid. Instead of being in fluid volume overload, I'm going to be in a fluid volume deficit. I'm not going to have as much fluid. And then with isotonic, those parts are equal. I've got the same amount of water as I do the same amount of particles. Be sure to look at, there's more information on this on page 968. Also, table 39.13 on 992 is your common IV solutions. Yes, 39.13 on page 992 are your common IV solutions. Let me know if that's not right. Yeah, page 992. I had a lovely friend, ChatGPT, to help me make this, to help you kind of understand it just a little bit better. But isotonic, iso-perfect. Perfect. There's a good balance of fluid and particles. Hypotonic, it'll look like a hippo. Hypo-hippo, I've got too much fluid. I'm swelling. Hypertonic, I'm gonna turn into a raisin, because I'm shrinking. I don't have enough water, so I'm gonna be shrinking and I'm gonna be dehydrated. Does that help a little bit to see in a different perspective? So isotonic, iso-perfect. Hypotonic, hypo-hippo. Hypertonic, hyper-raisin. Really shrunk like a raisin.
My A and B teacher said that when it's hypertonic, if you're hyper,
There you go. Hey, whatever helps you remember it, learn it, you stick with it. But I thought this helped. Everyone get a picture of it because it's not in your slide on your PowerPoint.